Alright guys, hey guys, today we're going to be doing a chair conformation. Let's just get straight into it. So it says to draw the chair conformation for cis-1 isobutyl 3-terpentyl cyclohexane, and to draw two chair conformations, which means the ring flip and the regular one. And then it says to label our groups as axial or equatorial, and then to circle the more stable conformation. So the first thing I'm going to do is go ahead and actually draw the layout of this molecule because it's not given to me. So one I know, and I like to start by looking at the parent chain, which is a pentyl cyclohexane, cyclohexane, sorry. So I'm going to draw that cyclohexane form right there, and then I'm going to go ahead and add to it. So I like to number, so I'm going to go number. You can number however you'd like for here, but let's go ahead and look at our attached group. So we have at 1, our first carbon, we have an isobutyl. Well, an isopropyl has 3 and it has that V. So an isobutyl, which is 4, is going to have 1 extra carbon and then that V. This makes it an isobutyl. 1, 2, 3, 4. And then the iso comes from the V shape at the end of the chain. Okay. And then at 3, you have a terpentyl. Terpentyl means you have a carbon that is attached on 3 ends to carbons, and there's 5 total carbons. That's where the pentyl comes from. So terpentyl is gonna be like this. We can verify 1, 2, 3, 4, 5. That is your terpentyl. 1, 2, 3, 4. That's your isobutyl. All right. So that's our molecule named, and now we need. Sorry, that's our molecule attached. So cis means two things. Cis can be that both of these groups are on wedges or both of these groups are on dashes. So because it's cis, you can just, I guess, pretend, put a wedge here. So sorry about that. So a wedge here. Yeah. And how cis and trans play into a chair conformation is that if a molecule is cis, its chair conformation, let's say, will have both in, say, the up positions. Like we have a equatorial up here, and then we have, say, an axial. Sorry about that. We have axial up here, like that. It doesn't have to do with axial and equatorial. It just has to do with the up and down. Just wanted to add that. Okay. So now let's go ahead and draw two chair conformations. So first, I like to do the actual backbone of the chair conformation. So this is how you draw a chair conformation. I just put 2 lines like this, 1, 2, and then I attach here. Oops, I attach here, I attach here, I attach here, and I attach here. You can do it in many ways. The ring flip is the same thing, just inverted. So instead of doing my lines this way, I'm gonna do them this way. So I'm gonna do 1, 2, 1, 2, 1. Oops, I never do them perfect, but whatever. And this is the backbone. I'm going to copy it because before we actually do it, we're going to go through axial and equatorial. So let's just look at axial and equatorial. So how does it work? So this is something you just kind of memorize. I'm going to only do it on this one right here. But this first, I'm going to number it. 4, 5, and this is a 6. So here, your axial's in the up position and your equatorial's in the down position. If you just memorize one, you can memorize all of them. Equatorial, because for every single one they switch. So if equatorial is down here, equatorial is going to be up here. So this is my equatorial up, this is my axial down, then the same. So this is axial up, equatorial down. This is my equatorial down. Oh, I'm sorry. This is my, I messed that up. This is my axial down, my equatorial up, and then vice versa, equatorial down, axial up, whatever. I'm just going to leave this one here so we can reference it. Okay, so number 3 is to actually place it. So let's go ahead and get started with this first one. So like we said, it's cis. That means they both need to be either up or down. I'm just going to go ahead and just choose up. You can do down. So at 1, we have a isobutyl. So at my first, I'm going to number 1, 2, 3, 4, 5, 6. At my first one, I'm going to go ahead and put my isobutyl, which is right here, and then I'm going to label it like it says right here. This is in my axial up, okay? And then my 3 tert pentocyclohexane, so at 3 right here, and again it's cis, so it needs to be in the up position, and the up position here is axial again, so up, and then you have 1, 2, 3, and again, you notice how they're both axial here. That's just coincidental because based on where the numbers are, but it's not based on their axial, it's based on the up. That makes it cis. If they didn't say cis, if they said trans, we would place it in the equatorial position because they would be in opposite directions. And that's it. That's your thing. So now you have to do the ring flip. There's many ways that people learn to do it. One way I learned to do it is just push your whole chain system down. So instead of this being 1, this is 1. So I have 1, 2, 3, 4, and 5, and this is 6. Go ahead and number again. So again, they're all in up position here. So at 1, you have your isobutyl. So I'm gonna, my equatorial is up. So I'm gonna add my isobutyl, and then my axial's down. I'm just gonna draw it to scale. Equatorial up, and then at 3, you have equatorial up. And then you have, I don't want to write that, but then you have an axial down, and then you have a 3 tert pentyl cyclo. Sorry. Okay. So this would be it. And now the 4th part, which asks us, let's cross this out, asks us to circle the more stable one. So which one is the more stable one? Well, the rule is that the more stable molecule is the one that has the larger, bulkier molecules in its equatorial position, because that yields less steric hindrance because it's not directly out, it's pointed out. So which one would that be? Would it be one in axial and would it be one in equatorial? It would be the ones in equatorial. So let's say you had one in equatorial and you had another molecule that was in axial. How would you answer that? It would be based on the bulkier group. You want your bulkier group. So in this event, if this was a trans molecule, this one being in equatorial would be more favored than this one being in equatorial because there's less steric hindrance. And that is how you would do this marble.